few days ago I released a video on completing the square, but it didn't have a whole lot in the way of visuals, so I'm coming up with a couple of more videos where I show you visually what completing the square actually means. In this video we're going to focus on using this sort of 4-area model, but I will also be trying to put out a future video where I use algebra tiles for those of you who prefer those. Okay, so put all equations into vertex form. That involves completing the square. Let's take a look at example 1. Now, x squared plus 8x plus 20. Now, we've worked with this 4-area model before, but completing the square is slightly different from factoring. We still put the x squared in this upper left region here, and that still means that these lengths must be x and x. So far, it's the same as factoring. But if you'll recall, when we were factoring, our job was to put the constant in here and then figure out how to fill these two regions in a way that makes a rectangle. That's not what we're doing with completing the square. Instead, what we're going to do is we are going to prioritize making this shape into a square. So this 8x needs to be evenly distributed into these two regions, or else it's not a square. So the only way I can make a square is to have 4x here and 4x here. A little bit of division will tell you that this side here is 4. How do I know? Because 4x divided by x is 4. Again, I'm just looking at the area of rectangles. Okay, same deal down the side. 4x divided by x is 4. So I now know at least part of my answer. Part of my answer is x plus 4 times x plus 4, better known as x plus 4 squared. Now the question is, what goes in this last region right here? Well, it's got a length of 4, it's got a width of 4, or base times height as you prefer, so it must be 16. That 16 is in that perfect square. The question is, what's left over? Because we don't have just 16, we have 20. So that leftover plus 4 is out on the side. So when we are doing this completing the square, we need to figure out how many, we need to figure out what the constant is going to be in order to make a perfect square, and then we have to adjust our equation accordingly. Let's take a look at another example. Y equals x squared minus 10x minus 10. Okay, so I'm going to divide my square up into 4 regions, same as before. Same as before, the upper left is x squared, making this side x and this side x. I need to distribute this negative 10x equally into these two regions. So that gives me negative 5x and negative 5x. Now I want to pause for a second because in my last video on completing the square, I talked about how your first step in figuring out what that constant is taking that b value and dividing it by 2. Why divide it by 2? That's why. Because we need to fill in those two regions equally to make a square. Okay, again, a little bit of division. With this side is negative 5 because negative 5 times x is negative 5x. This side also needs to be negative 5. Now all we have to do is fill in our lower right region. Well, negative 5 times negative 5 is positive 25. Now we already have a minus 10 out here, right? That's that number right there. We just added 25, So just like last time, we're going to take away 25 to compensate. So what do we have? We have x minus 5 squared, that's this whole thing right here. And then we have minus 10 and minus 25, which gives us a total of minus 35. Let's do another one. Problem 3. 2x squared plus 4x plus 5. Okay? Same deal. Section this off. And I'm going to kind of leave the plus 5 hanging out here for a little bit, and we'll figure out what to do with that later. Now, notice that we've got this 2 in front of the x squared. Well, we can't have that, right? Because if I had 2x squared in here, I'd either have 2x and x here, or maybe vice versa. But that doesn't help us because there's no way of making a square under those circumstances. So what we're going to do instead is we are going to make 2 squares. In mathematical terms, what we're doing is we're factoring out this 2 and focusing on the perfect square within. So we got x squared here, x times x. We've got 2x to distribute, so that's going to be 1x there and 1x there. Plus 1, plus 1. 1 squared is 1. If I add 1 on the inside, I have to subtract 1 on the outside. So my final answer is this square, except there's 2 of them. So 2 times x plus 1 squared plus 5 minus 1 plus 4. One more example. 3x squared minus 18x plus 100. So I'm actually going to give myself a little bit more space on this one to give you a more clear idea of what we're doing. So here's our perfect square, right? Here's the thing that we want to make a square out of. There's a plus 100 here. And because of this 3, we're not just looking at one square, we're looking at 3 squares. Okay? I hope this makes sense. So inside the parentheses, the x squared is still in the upper left corner. Remember, this is multiplied by 3, so this is 3x squared. Let's see. Negative 18 divided by 3 is negative 6. So I've got negative 6x to fill these two regions. So negative 3x and negative 3x is the only way I can do that and maintain a square shape. That means I have x minus 3 times x minus 3. And that means I have to add 9 because negative 3 times negative 3 is positive 9. It's not actually just positive 9 though, it's actually positive 9 times positive 3, so we're going to take that 27 back away. Remember that I can't just change things for the sake of changing them. I have to compensate somehow. So I hope this diagram makes sense, because this diagram is literally the equation, right? We just need to take away the drawings and put in just the letters and numbers. We get 3 times x minus 3 squared. Again, that's this whole thing right here. Plus 100 minus 27, some quick mental math, plus 77. And because I haven't been doing it so far this video, the vertex is therefore 3, 77. The axis of symmetry is x equals 3, and there is a 3 times vertical stretch. So if you prefer to learn visually, these diagrams are absolutely valid justification on an exam question. You don't have to do mathy looking steps. You can just use these diagrams. It works just fine. So long as you get to the correct answer and so long as your process is sound, you will get full points. I have a few more videos coming up within the next few days. Keep your eyes open. Thanks for watching.